I'm here with the Cerritos College team from the NExT Challenge, and we're going to be doing a live react to their test run in the Neutral Buoyancy Lab, the NBL, at NASA Johnson Space Center. So to break it down, NExT stands for the Microgravity Neutral Buoyancy Experiment Design Teams. It's one of our Artemis student challenges, and it tests undergrads to design and build a tool or a device to answer a challenge or a problem that we're currently experiencing in space exploration. So again, we have Cerritos with us here. Cerritos College is one of the largest community colleges in Los Angeles County, and it's also a minority-serving institution. They're also the only community college to make it to this round of on-site testing. We're so excited to have you guys here today. Let's get right into it and do some introductions. So Eric, let's start with you. Can you tell us your name, your major, and your role on the team?
Hi, my name's Eric Arias. I'm a mechanical engineering major, and my role on the team was to build the device, test it, and to also deliver the instructions to the diver when testing at the MBL.
Big role to fill. Yeah, we're super excited to see you in action on this test run. Michael, how about you?
Hello, everyone. My name is Michael John de la Pena, and my major is electrical engineering. And the role I filled in the team was as a design lead. So if it involved modeling on the computer, running math on the forces involved, that was on me.
Awesome. And we have one more team member joining us today from Cerritos, Samantha. Thanks so much for being here.
Thank you. My name's Samantha Stuckey Reynoso. I'm a chemistry major and I was the outreach lead. So I was in charge of K through 12 STEM engaging activities, where we would go to schools and basically present different STEM engaging things that the kids could have hands-on learning.
Yeah, I love that aspect of bringing the next generation like into the work that you were doing, like this really hands-on engineering and design. That's amazing. So what we're looking at right now for the audience is the Neutral Buoyancy Lab at Johnson Space Center, the NBL. It's a swimming pool that's actually 6.2 million gallons of water. It's at JSC because it simulates microgravity for our astronauts training to work on the space station, which really makes it the perfect location for this device test run that we're about to watch. So for you all, tell me how it felt to like get to the NBL and be there actually on site with the other teams. Samantha, can you start with this one?
Go ahead and weigh out the subject.
It honestly felt surreal. Like a week before we were about to go, I don't even think it settled in until I actually walked in through that door and saw the sign, "Welcome to the NBL." It's just incredible experience overall.
Michael and Eric, what about you guys? Same kind of feeling?
Well, yeah, I mean, we were the only community college there. We're going with a lot of big universities. They have, different amount of resources. We're a small school compared to them, so I guess we just wanted to show up and show what we can do as a small school.
Yeah, absolutely. It's really amazing that you guys could represent that group of community college students and show other community colleges that they could be a part of this challenge in the future. So that being said, I know you had multiple challenges you could pick from for MicroG Next, like different tests that you could do for your device. Which one did you end up going with? Like, what are we going to see in this test today?
So our team picked the calibration marker. So it's just this marker that you put on the lunar surface, and it's used to mark points of interest on the moon for different types of rocks or just geography that you'll find on the lunar surface. And then there's like a marker that'll tell you, oh, this is what you'll find here based on the color and all those little details that are already on the device.
Cool. So Michael, why did you end up picking that one? I know there are a couple to choose from, so I'm curious to see what the motivation was.
For the calibration marker, we decided on the challenge as a team, and the people had the most familiarity and enthusiasm for a device with it's closely resembles stuff that I guess they've used in their daily lives.
For
As
sure.
compared to, for context, there's the anchoring and the bag stowage
Oh, I
device.
think you're, sorry to cut you off. I think you're your test run's about to start, so we're gonna get into it here. I see the three of you in the control room. Can you walk us through, Eric, what's going on right now?
So right here, we're just getting ready to start the test. Our diver is not familiar with our device at all. So at the very beginning, I was walking him through how to use it, the little things he might have to move with his hands, because it is difficult. He has very thick gloves. He's wearing a lot of heavy gear, so it's not easy to move around. So I just wanted him to get used to, moving it, deploying it, stowing it, just before we start our actual testing that we had planned ahead of time.
Did you guys get to meet the diver at all and prep him beforehand, or is this moment like the very first time that you're interacting with him, like over that microphone call into the pool?
No, so I personally got to meet him beforehand. So before he got into the water, I was allowed to go just myself up to the pool with my devices and just give him a little walkthrough, like quick few minutes, just to give him an idea what it's like. But then once the diving started, I really went into more detail just so he knows what to do, and that way we can save time because we're timed this whole time. I didn't want to explain everything every single time.
Yeah. And so that's what's happening here now. You're walking
Yes.
him through.
Yeah, I'm just getting him used to device, making sure he's comfortable with it in his hands.
And I hear at some point you asked him for like to rate it. So what's the purpose behind that?
So because our device works off tension, you have to use a little bit of force to deploy it and stow it. And my rating is just like, how easy is it? Are you using a lot of force, a little bit of force? Is it too hard to deploy? Just like different things that might interfere with the gear that you normally wouldn't wear outside of the pool or on the moon, to see how comfortable someone can be on it, no matter who it is.
Right. I mean, it looks like it's working really well. Were you guys like happy at this point? How are you feeling like at this stage?
Oh, we were extremely excited. We're like, okay, at least it's gonna stand, right? The legs went down, the legs went up, right? He hasn't said like any difficulty besides maybe the placement of the little panel that's right there on the side where his finger's sticking up. He said it's just a little bit hard to put his hands there, but that's not a major issue, right? The device still will stand with that there or without it.
Yeah. Although I was excited about it, I was also just a little bit confused because the team before us used an opposite scale on 1 to 5, and so he'd rate it off of their
Oh,
scale, and
yeah,
he'd
that
just
sounds confusing.
so he's like, yeah, it's 1, it's really good, and then I'd be like,
You have to translate.
yeah, I was like, I think it's okay.
Yeah, that's definitely tough. How did you, so it sounds like you didn't have the exact same instructions as another group. So how did you decide on the instructions and the rating system? Like what was the process behind that that we're seeing now on screen?
So the way we decided is what we were comfortable with, right? At the same time, yeah, other teams were testing, but they also went what they're comfortable with. So we were just worried about our testing, make sure that we understand it, and if, he was used to the other one, we just made that simple translation. It wasn't a big deal when it came to the rating. So,
Gotcha. But all the different steps, like you guys got to come up with like what you were needing for those. Cool.
yeah. So we just
Yeah.
picked what we valued most in our device, right? What we want to see out of it, things that we normally can't do at home or like at school. We're like, okay, how close can we get it to being the real thing in the NBL?
And I remember there was a point where we started handing our device off to random strangers or people that walked by and just practice reiterating the whole 8 minutes that we had. So
That's
that was
so smart. That's a great
yeah,
idea.
just to practice and get us ready. But I mean, the real thing was obviously very different.
So let's like go back to the video for a second. What's happening here? So you already tested, you like got his rating on the functionality, and then what is he doing here?
So here he's just giving us like a brief summary of it. The first test was just to make it stand. We have 3 different devices and we put 3 different tests for all 3 different devices. We want to see like how far we can push it in the NBL. And then for every single one, he gave us a rating, a little brief summary of it, how comfortable he's feeling, any difficulties. So he's walking us through step by step what he's thinking and feeling as he's going through every device.
Gotcha.
Prior
It's so
prior
cool
to
to see him
deploying
like
it,
underwater
please
with your
place
device
sand
in
and
hand,
roll it
like doing
around.
all these tests. Michael, for you, I know you were the design lead. So what was the difference between each of the three devices?
So, when we manufactured these devices, I don't know if manufacture is the right word. We assembled these devices all by
Mm-hmm.
hand.
Please deploy the device.
Eric and his father, they helped out a ton with that, and our people at the physics department too. We the differences between the devices are more on uh, variations between us assembling it than it is by I intentionally wanted them to be different.
Right. So like the design is the same, but it would just be like minor tweaks depending on like how it was built. Like,
Yeah, it's the tensioning was a bit finicky. I mean, intuitively, the concept of attention was really simple, but tying that knot made us kind of regret it,
so I
especially with.
saw him like throw it around in the sand. Can you tell me what was happening there?
Okay.
Yeah,
Please
so
set the device
we
on the
wanted to
ground.
see how it would react if something were to go inside it, because there's a little bit of holes in it. We want to see if it will affect the device. So we had him bury it in sand as much as he can, in any way he could, and just to deploy it. Unfortunately, here is because more force was required. This was, I think, the test that really pushed the device. He had to use more force, and with the force, the little label broke off. And we're just like freaking out. We're like, oh man, like our label came
Please
off. What are we gonna do
open the device
now?
and attempt to start it.
But the device still stand. It's still stood up. It's still deployed. Yes, more force was required, but it worked as it intended. So we were a little disappointed the piece came off, but the test was still successful in some way.
Yeah. And I feel like the label coming off is a pretty minor hitch to
Yeah.
run into versus like the device not working. Michael, I know you mentioned before I asked about the sand, the tension device, or the tension aspect of the device. Could you explain that a little more?
Yeah, so the device is meant to
Okay.
be
On a scale of 1 to
handled
5, rate the ease of stowage.
completely near the top. So they have the handle there. The diver is handling it right now. And so you just take the handle, you twist it, and
Okay.
with
Now select
your
a
hand
different
only at the
device.
top of the device, you can just stow, restow with basically the same motion.
Mm-hmm.
And one of the things that
Navigate
we
towards the
were,
20-degree ramp.
brainstorming early on in the concept was having it be an unfolding tube. So not only would the legs unfold, but it would actually have like double the body size, and it would unfold in span. So it informed the way that we had the tension mechanism, and
Deploy the
we had
device and place
to
on 20-degree ramp,
sort
please.
of shorten the body, and that's why everything sort of overlaps there with the legs.
Yeah.
Yeah,
Cool. It sounds, I mean, honestly, from someone who's not a STEM major, it sounds like pretty intensive to like put that whole thing together and design like where the parts are going to go and everything. What kind of materials were used in the building of the three devices? Was there anything like unconventional that you used or
Please on a scale
pretty
of 1 to
standard?
5, rate the ease of deployment of that device.
In terms of the material, yeah, I think it was pretty standard. It was just stainless steel and aluminum for the most part, except for the 3D material that we use for the 3D printed parts.
Please
Mm.
But everything
rotate
else was
the
something you
device,
get almost like your local Home
hold off
Depot or
the
like your
side of the
Lowe's,
ramp
right?
and drop it.
The only difficult was like getting it of the measurement we wanted. That was the only difficulty, but the material is pretty common.
So what's happening on the slope here right now? I can see him like dropping the device onto it and it's sliding down a little bit. What test is happening there?
Yes.
So one of the requirements was that the device had to stand on an incline, right? So right here we brought them over to the highest incline they had down at the
Stow
MBL,
the
which was 20
device.
degrees. and we just had them put it on there, see if it would slide down or if it wouldn't. For this one, I was a little worried because it had sand on it. When we tested it out of the water, there was no sand, and sand will cause things to slide a little bit, so that's what happened. And then we're just having him drop it, see if there's any differences. It slid down a little, but for the most part, you can fix that, like just adding little boots on the legs. And then I remember afterwards, I was like, "Oh, can you please stow it and drop it?" Like when we were coming out with the operations plan, the team was worried. They're like, "Oh, you really want to drop it? What if it breaks? What if it?" I was like, "Well, we're here to test it as much as we can, right? So let's just go all out, have them drop it, see if anything happens, and then deploy it again."
And how did that go? I think he's looking at the result of that right now, right?
Yeah, right now he's picking up, trying to stow it, see if there's any difficulty. But it looks like everything went as we planned. It didn't break, and we only had a little hiccup with the label coming off on the second device.
That's amazing. So was that like akin to your expectations of how the device would perform beforehand?
I was pretty confident in the device. I remember the day before we took an extra one because we made 5, we only tested 3, and we went to the hotel pool and tested it down at the bottom of the hotel pool. We're like, oh, let's do one last second test here at the hotel pool, see if it works. And once we saw it work there, I was like, okay, there won't be issues at the NBL.
So Eric, you're not telling me you were nervous at all. You were so confident that it was going to work.
I was very confident in our device. The only issue is like when one broke right before the testing, we had to fix it really quick. But we had a choice of which 3 out of the 5 we wanted to send, so we sent our 3 best ones out there.
Gotcha. And Samantha and Michael, was that the same experience for you? You were confident the whole time that it was going to be, smooth sailing?
No, not at all. I just wasn't sure because, I mean, getting that tool to work, I mean, we had so many failures right before, up until the deadline, and the string had to be tied at the exact location. So tying that string and getting it to stand was like our very last thing that we had to do before we left. And so I didn't feel like we got to really test it as well beforehand. So it just proved to us that, I mean, we fought through it and we got it done, and we were able to come over to the MBL and test it. So
Yeah, and I mean that's part of engineering and design, right? Is like failing so that you can learn like what you need to change or fix. So it's a really hard and stressful part of the process, but kind of necessary, right? To know what needs to be done to succeed.
Yeah, and I was a fair bit more confident, because I mean, I was very familiar with the design. I had faith in the principles of it. Uh, the only thing that kind of shook me was the state of the devices after they were shipped. The shipping process was not kind to our devices,
Oh no.
unfortunately. And so it wasn't just calibrating the devices. I mean, calibrations were something we always wanted to do, but it was more double checking every single thing, and in some cases, reassembling a device from scratch.
Yeah, definitely. So I know we saw your test run end, and this is now just footage of more shots from the event. So what feedback did the diver end up giving you? I heard him say a few things, but what did he end up saying about your device?
Um, for a device, I remember he telling us that the label placement made it a little difficult to hold, right? That's why one broke off when it was a little harder to pull. Also, he said it was a little short, but we weren't expecting our diver to be 6'2", right?
True.
None of us are that tall on the team. So when I asked him to pick up the device without bending over, he's like, "Well, I'm 6'2", it might be a little hard." And I was like, "Oh, like I wasn't expecting such a tall diver." And then another issue was the legs. They floated a little, but I think that can be fixed, with how you hold the device or just readjusting the string a little bit. I don't think none of them were like major issues, and it worked as we planned it to be.
Cool. Yeah, I was gonna say, I'm glad you said none of them were major issues because I also heard him say at the end there that he really liked it. Like he gave you the feedback, then he was like, "But I really like it, like great tool," or something along those lines. I know we were talking, so I couldn't hear the exact quote, but how did it feel to have like the test person give you that kind of feedback too?
Felt great. I mean, he's basically us telling we accomplished what we were asked to do, right? We didn't. It was a little bit of a complicated design. We did fail a lot, but in the end, it worked. He said he enjoyed it, and we met all the requirements. So I guess you just feel a sense of accomplishment, or like you finally finished it. You're done with it.
Yeah. So like having gone through this whole process, what advice would you three give for other students looking to be a part of this challenge in the future? I think we'll start with you, Samantha.
Definitely plan your schedule accordingly to like meet the deadlines. It does take a toll on your class load and everything else. It is going to require a lot of time. Um, to say the least, I just think it was overall a great experience. Definitely, I think meeting with others at the NBL was amazing. So if you can get the chance to do this, I would definitely recommend it for anyone.
Michael, how about you?
Um, I would wholeheartedly recommend it. Um, I I would suggest like following through what Samantha said about scheduling properly. This is quite a large commitment to make, you know, and it's the sort of thing that happens all throughout the year. So you have exams, you have your finals, but the show must go on in terms of the project. And as for, I guess, other engineering majors like me, I wholeheartedly recommend this. If you if they've taken some of the classes, you learn about like the principles, like, oh, you gotta fill in this table to make decisions, or you've got to follow this process to design it. And you get to actually, practice all of that. You know, uh, the way I had to practice these sorts of things in my classes were like small group projects that you don't quite have enough time to really flesh out. But, this is 10 months, right, guys? 10 months of our lives?
Yeah.
Wow.
Yeah, so like in terms of the design side, it was the most engineering I've done as, just an undergraduate student.
Yeah, that's amazing. It's really cool to hear you talk about that. And I also love the advice about students like planning ahead and knowing the time commitment because it is such like a real world application, right? Like you're literally making things that could potentially be used for future missions to the moon. Like you're solving a real world problem. You have a timeline of, you know, many months to kind of like work through all those kinks. Like it's probably the closest you can get to actually working for a company or in your career on something like this. Eric, what about you?
I guess the device would be is like I'm an engineering major. I've seen some of these ideas that we used here in my classes, but I guess not be afraid to take ideas from non-engineering majors or someone outside of it. Like for the design, a person who helped a lot was actually my dad, right? My dad works in construction. He doesn't know anything about engineering, right? So like some of his ideas are actually in this device. The construction, we're using some of his ideas how to build certain tools, right? And then I just later recreated them or just showed it to the rest of the team, and then we built all the devices. And then I guess another tip would be this is more for like community college people. It's like don't be afraid of the big schools, right? There you can go there. It's not a big deal. Like we went schools that were sponsored by Boeing and like all these major companies, and we're a small school in like California, right? So like, don't be afraid as a community college student or a small school like to go there and I guess show off.
I love that. That's like the perfect message to end on. Thank you all so much for being here. It was really amazing to hear your perspective throughout your test run and kind of do that live react with you. So thanks again for joining us.
Thank you.
Thank
Thank you
you.
for having us.